This is section 3.1 and we're looking at solving simultaneous equations. And first of all, we're starting with linear simultaneous equations. So that means we've got no x squareds, we've got no y squareds, we've got no cos, sine, tan. We've just got x terms, y terms, constant terms. And at GCSE, you learn two different methods, elimination and substitution. We have the same problem we have with chapter 2, which is how far back do we go? You know, I can't recap the whole GCSE course in these videos because I'm just trying to get the A-level course done. But what I will do is say elimination is often the one that people prefer at GCSE. You might like both of them equally, you might prefer substitution, but elimination is often seen as the easier one to do. I don't really understand why, if I'm completely honest. I think they're both about as difficult or as easy as each other. But what you need to do now is get your head into substitution. The substitution method is the one which is going to be more useful. And the simple reason is, if you've got two linear equations, elimination might well help. But if you've got one linear and one not linear equation, substitution is much more likely to be useful. And in section 3.2, when we look at one quadratic and one linear simultaneous equation, substitution is going to be all we're using. Okay, so if you're happy with solving simultaneous equations by elimination and substitution, then you can do exercise 3a, put plenty of practice in, make sure you can do it easily. I'm just going to go through an example of substitution, just in case that's useful to people. If you're confident with substitution, I'd suggest you practice the exercise and move straight on to section 3.2. So I'm going to look at, let's take a nasty one. I'm going to take part B from the example, because this is not an easy one to do by substitution, right? This is looking at a mess by substitution. So let's make sure we can do the harder version of it. I've got two equations. I'm going to label them equation number 1 and equation number 2. Okay. Now I need to take one of those equations. Let's say I'll take equation number 1 and I'll rearrange it. And I'm going to rearrange it in such a way to get an x on its own or a y on its own. And it doesn't matter whether I'm getting x on its own or y on its own, either one, right? So in this case, it doesn't look like there's an easy option. They've both got coefficients. So I'll get x on its own, why not? So 4x equals 4 plus 5y. So x is going to be equal to 4 plus 5y, all divided by 4. And I'm going to call that line number 3. And then I'm going to substitute from line number 3 into line number 2. So that means x is equal to this thing here. So every time I see an x in this line, I'm going to write this thing here. So I've got 6 times by this. Okay, so there's an x there, but that x can be replaced with this. So when I see an x, I'm going to replace it with this. Plus 2y equals 25. Now what I've got here is I've got an equation where there's only a y. Y is the only unknown, so I should be able to solve this equation, and also it's a linear equation, right? So it's a linear equation with only y. There's no x squares, there's no cosines, there's no square roots, so it should be straightforward, just collecting like terms and so on. So let's expand these brackets out. So 24 plus 30y all over 4 plus 2y equals 25. Let's think of this as two separate things. So 24 over 4 is 6, plus 30 over 4, which is 15 over 2. I'm just going to leave it as 15 over 2. Y plus 2y equals 25. Take away 6 on both sides, and I get 15 over 2y plus 2y equals 19. Where does that leave us? That's 9.5y equals 19, isn't it? Which is 19 over 2. Y equals 19, which is giving us y equals 2. Okay. Once I've got y equals 2, I can take that and substitute it in. So I'm going to try and squeeze this in on one page. So y equals 2 into, now I can pick equation 1 or equation 2, it doesn't really matter. I'll go for equation 1. So I get 4x minus 5 lots of 2 equals 4. And that means that 4x equals 14 and x equals 3.5. Okay, it's always worth it, if you've not seen this a whole bunch of times before, just take those two values and put them in here. So 6 times 3.5 plus 2 times 2, well 6 times, I'm not going to do the calculations in my head, I'm going to let you do it, but 6 times 3.5 plus 2 times 2 is going to be 25, okay? Okay, so there's one example of substitution. It's worth pointing out that these lines here are really important. I can't just go from this to this to this because it's not obvious where this line's come from. I can't just go from this straight into here because it's not obvious where this line's come from. You've got to tell me what you're doing. So these lines, a lot of students miss out, and they're absolutely vital to making your working out understandable. Once I get to here, this line just follows on from this one follows on from this one, and so on. So this is just a story written down the page like anything else that you'd read. I'd expect you to understand this because it comes out of this. This line, well, I can see where that's come from, I can see where that's come from. This turns into these two terms, and I can see where they've come from. If it's not clear, I can put in an annotation, okay? Once I get to here, y equals 2. Well, the next line, if I miss this bit out, 4x minus 5 times 2 equals 4. Why is that true? The only reason it's true is because I'm taking this bit and this bit from way up here. So I need to put a line in to explain that because it's not obvious to somebody reading it. That's not just a case of making it clear for somebody reading it and making it so that the examiner can see it. That's also you setting out your thinking clearly, right? These 3 stages are actually the important stages here. Everything else is just fiddling with algebra, okay? So having that clear in your head will mean that you're less likely to make mistakes in the first place because you understand the bigger picture and you're setting that out clearly, okay? So that is our substitution method for linear equations.